Okay. Good noon, my dear students. Let me recapitulate whatever we discussed yesterday. Okay, we were discussing about the central tendency and the dispersion of the collected samples or the sample statistics. And we were discussing about the relationship between the universe or the population and the statistics. Usually the universal parameters or the population parameters are represented by average value deviation is represented, okay, and sample statistics usually they are represented by X double bar and this one standard deviation, that small s. Okay, because why we need to study about these things is when we are trying to establish the control limits or when we will be studying about the control charts, these will become more vital because we need to construct the control charts. That means we need to find out which control chart is to be used. The control chart is to be used based on what quality characteristic we want to measure. That is what we need to understand. Okay, and then we studied the various means of central tendency, different means, namely mean, that is arithmetic mean, mode and median, and we selected arithmetic mean for the arithmetic mean will be the best. And second, we thought about different ways of measuring the dispersion, and we identified that the range and standard deviation are the best things. Okay, even though we have got mean absolute deviations, like that, we concluded that the standard deviation and the range are the best, and then how to make use of them and other things, that is what we need to think about it. And we have also, or we have established the relationship of these things. What? How the sample statistic will measure the population values or the population parameters. Actually, what we want is, actually we should have measured the population parameters first. Then only it becomes easier. But population parameters, if it is measured, found out, the lot of effort is to be put in and a lot of money as well as the time has to be spent. It is just like, my dear students, it is just like predicting of the result of the elections well in advance. In fact, the statistics terms itself was developed because of these reasons. That is what we can say, that things, the exit poll or before the poll itself is conducted, who are the candidates who are likely to win the elections and other things. How can they calculate? They will take the sample. Based on the sample, they are able to predict the outcome because thousands of people will be voting, or thousands of lakhs of people will be voting, and they are able to predict that one with a certain accuracy, which will depend on taking the sample. Same thing here in manufacturing, because we are going to apply this statistics for manufacturing. I want to see whether or the manufacturing people are interested in seeing or predicting that what of the affected, whether the company is producing the right, the quality of the product or not. If it is not producing right quality of the product, can they take some preventive actions? Because what is most important is preventive actions, not corrective actions after the event is over. If we are taking something, no, it will become only the postmortem. But sometimes the postmortem can be used for future planning purpose. That is what, because after the company has produced or the firm has produced the number of defective parts, then it will start realizing, because no longer it can save or it can save the money, because the only in the competitive business why these things have become more prudent nowadays is it is no longer the market, whatever is there, it is no longer the seller's market. It has become the buyer's market, because whoever is going to buy the things, or the customer is the king. Earlier it was not so. Whoever used to manufacture or sells the thing, he used to dictate the terms to the customers. If you want to buy, you can buy only this one. That is what in one of my lectures I might have told, how the Ford company miserably failed, because when Henry Ford said way back in 1912 or 12 that if anybody wants to buy the Ford car, it can be black. It cannot have any other color than black, because he wanted to keep the production cost less. But as usual, the people, they are not happy with these things, constant or uniform and other things. They want to show that they are superior to others. That is the natural human tendency. They want quality characteristics. If there are 10 people, they want 10 different things to be incorporated in the product. But the manufacturer is only one. He needs to gather these things and try to put in maximum number of customers, and how it can be done. Okay, that is the thing we need to learn about it. Because earlier, when it was the seller's market, they went for the mass production. And what we are discussing about this repetitive process for this thing, usually it happens in mass production. Nowadays, almost it is coming to the job type of production, but the size is not exactly one. It may be in terms of 100. Earlier, it used to be in terms of thousands or lakhs. Now, it is in terms of tens or hundreds. That is what we say, that batch type of production. Still, some repetition work is carrying on there. So, still batch type of production. We can apply this control chart to control the quality. But for job type of production, again, I repeat, it cannot be applied. That is why is asked, then you need to say that it can be applied only for the repetitive process. That means mass or batch production, not for job type of production. Establish the relationship between the population and the sample statistics. Okay. That means the relationship between this mean and the standard deviation of the sample with respect to the population mean and population standard deviation. And we also established that if the process, it is not necessary that process has to follow, it need not be. Even if it doesn't follow any type of distribution, but if we try to draw the graph of sample means, then always it will follow the normal distribution. That is why those things have been discussed, and we established the following things. What we established was the mean of samples or mean of the average samples. That is what already we have seen, because we categorized into number of groups. That is what we say subgroup size. It needs to be between, it needs to be not less than 4 subgroup size, whatever the sample. That is what I had given an example. Consisting of 5 values. And for each of these groups, these are the subgroups, that is what we say. How many subgroups? It depends on whatever total number of samples we are going to take. But how many samples? It depends on what is the accuracy we want. And how much in reality the total number of going to be, the population value is going to be. If it is larger, then perhaps we may have to take more samples. Size should be more. But in one thing you need to understand, in case of statistics, we'll talk about large sample, small sample, like that. Large means what? Is it going to be in terms of lakhs or crores? In statistical purpose, my dear students, you try to understand. Infinite or large means if the value is more than, this is a very, very important thing. In more than 50 is infinite. Less than 50 is finite. But for us, even crore may not be the big amount. It might be small amount like that. But in statistics, it is virtually 50. We can don't put that cut mark as 50. Don't ask whether 49, whether it is to be considered or large or small, like that. This is some demarcation. That is what they have put. Okay, that means finite means less than 50, infinite means above 50. That is what it means. That is why the sample size will never cross certain values. Okay. Now, if this is the sample, want to find out the population or the universal parameter. For example, I want to find out x bar prime. How these are related, that is what we have to understand. We say that or we can say that x is the best estimator of the population average, namely x bar prime, or it can be represented by mu prime. So that means x bar prime can be found out by finding out this sample means. Okay, this is one thing we have. The second thing we have seen. What about standard deviation of the population? The standard deviation, how much? That is what we need to find out. Okay. So it is sigma prime. That is what we need to understand. Or they are related, the sigma x bar the standard deviation are n size. In this example, we have taken subgroup size. If I increase this instead of 5, if I make it 6, if I make it 8, if I make it 10, then the sigma x bar, it is going to be reduced. That dispersion is reduced. Because that is what we can see. If the sample size increases, then the dispersion will be reduced. That means that we are more confident. Okay? But if the sample size is less, the variation is more, the area that the spread is going to be more. That is the crux of this one. The other things, what are the things we established? Find out the range. Through the range, is it possible to find out the sigma prime itself? For finding out the average value, there is no problem at all. Where R bar is the average range. That means for each of these groups, range is difference between the large and the small value in that particular group. That is what has been explained. That means R1, R2, like that. We can go up to R4. And R bar is equal to this R1 plus R2 plus R3 plus R4 divided by 4. This is R. That is what we are going to find. It can be easily estimated. Then the relationship D2 is the factor which entirely depends on the subgroup size. Here the subgroup size is 4. It might be, a subgroup size is 5. So in some cases it might be 4, some cases 6, 7, 8, 9, 10, 11, 12, whatever it is. So these D2 values have been found tabulate. And also it was told, or we found out that in 1920s or 30s that there was no computer and other things. The computational problems were there. Hence the people resorted to shortcut methods. And it served that purpose. Even now it holds good. So these D2 values have been tabulated for a particular subgroup size. So these things are available in the form of table. And this R bar values, we can find out, actually measure it, and then it is possible to find out the value of sigma prime, or is equal to R bar by D2. So sigma prime you can calculate in different ways. Okay. Now here sigma x bar is equal to sigma prime divided by square root of n. So how the relationships are, you just try to find out. So what is that? Why I am giving you these relationships is the calculation of this sigma x bar and other things, because actually when we want to go for control charts for variables, even now I might not have defined what is the control chart for variable and what are the different control charts for variables, but we need to compute sigma x bar and x double bar values. And how these values are computed, that is what I am just explaining with the help of this one. If sigma x bar is to be calculated, we have to go roundabout way. Okay, that is what I explained in the previous lecture. But if I establish these relationships, that means that range is very easy to find out, because it is the difference between the smallest value in that particular group is the range. Likewise, I will find out the average range value. It is very easy to find out. Okay, and it can be from the table. We can find out the value of D. Sigma prime can be found out. If sigma prime is found out, then we know the relationship between sigma x bar and sigma prime. This is the thing. Again, the subgroup size, square root of n, which is d2, whatever the subgroup size, we know that's square root of n, that value itself. So hence sigma x bar can be found out. If sigma x bar is found out, then it is very easy to establish the limits for the control chart. That is all the crux about this one. Is it understood? That means these are the things. Again, we know that this one also we talked about. Okay, if you remember correctly, there also we have seen that so for each of these subgroups, either I can find out R1, R2 like that, or I can find out sigma 1, sigma 2 like that. So for this total number of this subgroup, average value of R I had found out. Similarly, I can find out for this one sigma bar. And from knowing from sigma bar, sigma prime can be calculated by using this relationship. Once sigma prime is known, again I can calculate the sigma x bar. Okay, this is the basic thing which is required for the control chart for variable. Okay, that is why we need to calculate this one. And again, we know that sigma bar. And to calculate sigma 1, that depends on the value of C2 can be found out, find the tabulated value. These things, after a lot of research and other things, these values have been tabulated. We need not have to worry about that one. This is the whole crux matter of these things. So these things, you need to understand these relationships. And these will form the basic thing about control charts or developing the control chart. Next, what we need to some basic. So in that about because quality of or anything, it might be the miserable one or it might be judged one. Miserable means we can express them in terms of the values. Its length is so much, breadth is so much, like weight is so much, like that. But in case of judgmental values, it is good or bad. How much good and how much bad, I cannot distinguish like that. That means it is counting. What percentage are good, what percentage are bad, like that. It is just counting. Okay. Then this is the difference between attribute and the variable. So variable can take any values, maybe negative also. We compare, and it can go up to any fractional values also it can take up, or we can say that it can take any real value. Whereas attributes, necessarily they are to be the integer values. In between values it will not take. And we cannot thought about minus value or something like that. Okay, negative values. So that is how the probability comes into. The probability can be measured or it can have only two values. Probability, it can be greater than or equal to 0. It cannot be more than 1 also. Probability, whatever is there, it can have the values between 0 and 1. We cannot say minus 200% probability. Wrong. I can say 200% probability. Wrong. It can have the value between 0 to 1. 100%? Yes. 0%, that means it will never happen. 100% means it will happen. And it might be in between. 50% it may happen, 50% it may not happen. For example, it may rain or it may not rain. But if it is a cloudy weather, it is more likely that it is going to rain. It doesn't mean that if there are clouds, it should rain 100%. No, still I may not be sure. But it gives us some comparative things. That is why which is more like, that is how the probability is defined. Likelihood of happening of the things is called as the probability, which is more likely to happen. That is what here also we are going to find out. This quality. If I proceed like this, this is more likely is going to be the outcome. That is what, that is how this probability is closely related with respect to this subject. Hence, we need to talk about certain distributions. That means because when we are playing with the numbers, so these numbers always they will follow certain distribution or certain frequency. And also I told you, probability is nothing but the relative frequency also is called as the probability. Hence, depending on the quality characteristics, we will have different probability or different distributions. Now, mainly distributions for the characteristics, that means one it will take only integer values. Try to understand, not negative values. Why and other things I want to discuss in today's class. That is what precisely I want to do, so that it will lay a sound foundation for understanding further things, especially the numericals which we are going to solve. Because let me tell you, most of the engineers, we are afraid of this probability. The moment we hear the word probability, we try to run away. Don't do that one. It's the simplest thing once it is understood. And here, we are not going to do in much depth. We are not going to study about that in much depth. We are bothered about the application of that probability. That means which probability distribution is to be applied and when. Only that much we are interested. So that is what I am going to explain in this particular class. Okay. So this quality characteristics, the quality characteristics, that is what I said. It can be actually measurable, not measurable value, that is variable. We call it as variable characteristic. Length, width, height, weight, like that. But certain things, they are, and here height, weight, whatever it is, in between values also they are going to take. So other things are, some things, attributes. These are some judgmentable. It is present or absent, like that, something, attribute. Okay? That means, say for example, color of the hair. How much black it is or how much white it is. Okay, that means it is there or it is black or it is white, like that. It is going to take these things only. Or it will take it in the form of steps. Say for example, mark score. Also we can think about that. Okay. That means the variable means it can take in between values, but attribute is no. What are the various means of reaching this one? Don't say, okay, I want to take the lift and something. Don't bother about that one. That means slowly this will go on increasing. That is the thing. It has got. Another thing is what? It will discontinue this one and again it will move like that, in stepwise fashion. This is continuous. This is continuous variable. This is stepwise. This is what would make us the clear about attribute and the continuous. Okay, that means this is in stepwise fashion. It is in continuous. It is only in will take. Okay, that is true here. It will take in steps on integers, starting from 0. Okay, that is what we can think about. Then the distributions, if distribution, in normal distribution, how it will behave? Why? Mean value is at the highest frequency is at the mean value, and as it goes away from it value, it goes on decreasing. Ultimately, in a long run or at infinity, it meets this. Otherwise, it will become asymmetrical, bell-shaped. It is called as normal. You might have observed the sand because the truck is there, and when he wants to put it on the floor, that sand is to be transported onto the floor. The moment he lowers, what shape it will take? It will take almost like this shape. That means heap of the sand or heap of the soil and heap of the small pebbles. But if they become larger and larger, no, it is totally different. Okay, that is how it is going to shape. That is what the nature itself it tells. So in long run, all the things will be converging into this one. This is normal distribution. Other distributions are maybe things, but I am not, we are bothered only about normal distribution. Normal way, because we know that if they are due to the, if there are the variations are due to the chance causes, then it should follow the normal distribution. That is why I am talking about this. If it is not normal, then there is something wrong. We can we can assign certain reason for that. Okay, so this normal distribution, and it can be completely defined by one is the mean, another one is the standard deviation. How they are related? Because this is why How it is to be applied and other things, we can find out, we can see later. Just I am giving you the brief thing about that one, because this lays, that is what I said, this lays the sound foundation. Standard, normal, variate. I don't understand. This much is sufficient for us, okay, right now. And this z is equal to x minus mu divided by sigma. Okay. When here you can observe what has happened here. When this z becomes 0, that means e to the power, anything to the power raised to 0, it will become 1. Then it will become only this one. Just try to understand. And this, these are the parameters. That is how, because if I know mu and sigma, I can find out, manipulate or find out anything out of it. What percentage will be falling here, what is that probability and other things can be calculated. Okay. Now, that is why because values, they are going to the normal distribution only. And now, next one is for attribute type of attribute values. Okay. Now, hypergeometric distribution, Poisson distribution, binomial distribution, like that. And ultimately, they will all lead to normal distribution only. Because normal distribution, all these things can be approximated by this one. Okay, fine. But again, two things will approximation in the sense. One is, what is the cost involved? Because it is nothing but the optimization between the cost and the accuracy. Cost in the sense of what? Time. Because for applying these things, more times are required. To tell you the fact, if I want to calculate the probabilities by using exact the values, that means accuracy will be very high. But at what cost or what time? Hypergeometric distribution is accuracy will be very high. But time it takes will be more. Next is this, like that. This is easier to apply. Compared to this one, this is easier. Compared to this one is easier. And compared to this one, it is much more easy. That is why most of the things will be using the normal distribution. But it doesn't mean that always we should use it. Okay? Ultimately, they will follow the normal distribution only. So, for some of the control charts, we are going to use binomial distribution and Poisson distribution. And for some these things, many of these things, normal distribution. And when we are talking about the control charts for variable characteristics, we are going to use that the x bar and sigma x bar values we are going to find out. Okay? And when you are talking about attribute type of control charts, that means the quality characteristic is attribute. It is not variable. It is defective. 10% defective, 20% defective, like that. In that case, I got to use different control charts. That is usually control charts for attributes. That is how it has been categorized as control charts for variables, attributes. So I am discussing here, maybe for under 2-3 classes, we will be discussing about the control charts for variables, but nonetheless, they have got this, they are based on these basic premises. That is why I am taking this opportunity to explain about those things, so that in subsequent classes, I need not have to repeat about the same thing. Okay. Now coming back to this one, hypergeometric distribution. Okay. This should be the quality, that number of defectives. That is what, let me say. Percentage of defective or number of defectives, whatever it is. That means X is defined as number of defectives. It is going to take a particular value X. So there are a number of defectives. It might vary from some value to this thing. I am interested in finding out what is the probability that if I take a sample of some 10, what is the probability that it contains one defective? That means X is equal to small x is equal to 1. It will take a particular value of that. Or what is the probability that it will consist of 2 defectives, 3 defectives, and up to 10 defectives. Which is more probable to happen? That is what we are interested. Okay. More probable and least probable. That is what likelihood of happening of those things we are interested. Distribution. One is some knowledge about, and especially in probability calculations and other things, we are more interested in combination than permutations. What is the difference between the two? Permutation and combination? Yes. The difference is the order. In case of permutation, order is to be maintained. In the combination, any order. It doesn't make any difference. Say, for example, if I write, if it will give you the meaningful this thing in this order. If these things. In combination, anything is possible. Okay, that particular order is not mentioned. So, usually, mathematically, it is how I can select the order. It should be first, it should be second, it should be